Hey everybody, my name is Tyler Lay, and in this video, I'm going to interview Chris Luebkeman. I met Chris in May 2019 at the American Society of Civil Engineers Education Summit. This is where ASCE got all kinds of academics together to talk about the future of civil engineering, what our students need to be successful and make a difference in the future. It was an awesome meeting, but Chris was our first keynote speaker, and he blew our minds. He was unbelievable. Chris creates these mental models or frameworks that helps organize the future of society. It's pretty awesome. The future's tough for people. I know in this meeting it was extremely tough because we don't know what's going to happen. It's murky, it's strange, and it scares the bejesus out of a lot of people because they don't know how they fit. But Chris has this awesome skill to break things down so people can see themselves in the future or some version of the future and then better plan for that. Walt Disney said, "If you can dream it, then you can do it." And that is a perfect quote to start this interview because that's what Chris helps people do. He helps them take their dreams, see where they fit, see what's going to work, see what isn't going to work for the planet, for their people, for their company, and for society. I gotta warn you, I geek out several times in this interview, and that's just because I think the stuff that Chris is talking about is just so cool. I hope you enjoyed this interview as much as I enjoyed doing it. Hey everybody, thank you so much for being here today. This is another interview session with a futurist, a person that can see into the future and can predict what things are going to happen. I'm not even going to tell you about what he does because I don't think I can do it justice. We're with Chris Luebkeman, who is a Arup fellow. And so Chris, when someone asks you about what you do for a living, how do you answer that?
Well, Ty, I think the easiest thing is to say is my job is to help make sure we're still in business 20 years from now. Because that's right. But I just want to correct you on one thing. I do not see the future. I help us and our clients and our friends and colleagues think about what's changing in the world so that we can create strategies and plans to deal with that change. That's really my role.
Well, that's pretty awesome. And you've got a really unique background. Can you tell me a little bit about that?
Well, I started off studying civil engineering and geology, got 2 degrees at Vanderbilt, and then I went up to Cornell to focus on structural engineering, researching high-strength concrete, long-term deformation of high-strength concrete. Minored in business and the history of architecture. Then I went to Switzerland to study bridge building with Christian Men. And after about a little bit less than a year, I went to work for the office of Santiago Calatrava, where I did most of the structural modeling for his buildings in the early days. And then after that, I went back to school in Zurich to study architecture. And I spent the next 6 years doing my PhD in architecture.
Chris, dude, you're a stud. You just listed a who's who list of structural engineering schools, of structural engineering people. I mean, dude, I'm even more excited to talk to you. So thank you so much. This is a strange one, but this is one that I hope maybe you can help people better understand yourself. And this is a weird question. What is your greatest failure? And I don't mean like the biggest boo-boo you've ever made. I mean like a mistake or mishap or something that you learned a lot from that made you better.
Well, yeah, so that's a really interesting question. It's not asked very often, but I think it's a perfect one. I learned at Cornell, when I was in grad school, a really good lesson. And that was be really careful about what you assume as input and what you assume as output. At that point, I think I was the last class at Cornell to actually use punch cards, just dating myself a little bit. And we had to write our own matrix analyses, and it was very early days with computational analysis and engineering. And I was doing a little bit of consulting on the side for a guy named Ray Di Pasquale, and we had a failure of a stairway on a hotel. And he asked me to run some calcs for him because it was a very complicated dynamic analysis, which couldn't be done by hand really. And I did it. And I went and took the results to him. It was like this tome of like 2 inches of stuff. And I was really proud of it. And he sat down and looked at me. He looked at it, and about 20 minutes in, he said, "Chris, what's the formula for the moment of a simply supported beam. And I said, well, 1/8 WL squared. And he goes, okay, so how wide's this beam? What's the load? And what's that number? And I looked at that. I told him what the, and I looked at my output was complete garbage. And so what I learned was, you can't just trust a calculation to be right because you put what you thought was correct information in. You really have to check your assumptions, just do some simple calcs to see if your output and your input even makes sense. And I see that today with critical thinking. I find many of our young graduates we hire have lost the art of critical thinking. Just because you see a representation through an analytical program, you think it's good. But don't even take the time to just do a quick 1/8 WL squared to see if does this output make sense. So that was a really, really great lesson, I'd say pretty young in my engineering career. That was a failure. And I'll tell
That's
you another,
awesome.
let me tell you another one, Ty. Another really, really, really great lesson I learned was when I went to work with Christian men. And I realized that there's a massive difference. Well, what I realized when I worked with Christian men, there's a massive difference between engineering design and engineering calculation. I had been trained as a calculator. I was not a designer when I went to Switzerland. Because Christian men talked about bending forces and helping shape the way they moved through a beam or through a structure and feeling these forces. And at Vandy and Cornell, we never talked about feeling forces. We talked about how you calculate them and how you resolve them through a hinge. But men talked about them almost as if they were alive. And it was quite phenomenal to me. It baffled me at first because it's like, man, this isn't real engineering. And then I realized, actually, what he was talking about was truly design, where you're looking at an outcome you're trying to achieve and the beauty of it, and not just trying to resolve a vector. And so that was another really great lesson. It wasn't a failure, Ty, but it was a really important lesson in my life there to understand the difference between calculating and designing.
No, man, I think that's well said. I always tell my students you have to become the force. You know what I mean? You have to live it. You have to see it. And I think that's really well said. Now, hey, I have to ask something else because you brought up Men, who's one of my heroes, by the way. I heard a story that he could get on a plane on maybe Switzerland or maybe the East Coast United States, fly to the West Coast, and he would have a bridge design done. It would be done. He'd hand him like a stack of the calcs, and it would be right. He'd have all these hand calculations and simple methods he would use to do things. And I think that's just a guy after my own heart. You know what I mean? This idea, this person that can see and feel and live a structure, but also can do something like that. Is that true, or is that made up? What do you think?
Well, I would say partly true, Ty. I think there's a bit of urban myth in that all the calcs would be done. But he was a very graphic thinker because he was trained. So I'll start back a little bit further in the story to help you appreciate the genius of men and a lesson for us today. When he was young, he contracted tuberculosis. And in those days, when you had tuberculosis, the cure was to go up into the mountains and let your lungs clear out and clean out. So he had an extended period of time when he was at university, when he was forced to lie in a bed or sit in a chair up in the mountains and breathe clean air. Now, for someone with an incredibly active mind, that could in many ways be torture. But what he did is he took books and books and books and learned and read about graphic statics and how to use graphic statics and about materials and concrete and the great designers of the day. And so he came away from that with a deep appreciation of the simplicity and being able to resolve forces through vectors. And so he used that inherent knowledge to design. So yes, he could get on a plane and land with designs in hand, but not necessarily the complicated calcs which we require today to make a Department of Transportation happy. Because you can't do dynamic analysis through graphic statics. You can resolve forces and really get a great feel, but not that. And yes, he was an absolute genius and beautiful bridge design and responding to the needs of the forces as he would manipulate them. So partially true and partially not. Yeah.
Oh, that's cool, man. Thank you so much for that story, and I'd love to dig in more into that. But I am going to talk about the now and the future, and I know that's what you're excellent at. And I want to talk about autonomous vehicles. So tell me about your work and what you've been doing with autonomous vehicles.
So Arup has been involved with autonomous vehicles for almost a decade. Probably at least a decade, and what we started out with was thinking about the potential impact of the Internet of Things on the built environment. And the Internet of Things incorporates and includes objects which move, objects are static and not just the concrete bits, but lighting poles and park benches and everything else. And we were asked by Singapore Department of Transportation, called the LTA, the Land Transit Authority, to help them and help the nation think about what the potential opportunities for autonomous vehicles would be on the country. So we spoke with the heads of all the ministries, and whether it's health or education, housing, et cetera, and talked to them about how autonomous vehicles could potentially impact their mandate, which it was really fascinating. And out of that, we then created a series of workshops where we took some of the typical, in this case Singaporeans, these typical users, thinking of various types of citizens, like a single father with 2 kids, a mechanic, a young person going to school, an elder who's retired. We took a sort of a view of these people's lives and how mobility and integrated mobility options, including autonomous vehicles, would play into their lives. And so out of that, we created a strategy. We're with the LTA. We helped create a strategy for implementation of autonomous vehicles and a series of trials. But the big learning that came out of it, actually, for me, was, in this case, the importance of the first and last mile. Because in most successful large cities, you have a robust public transit system, which is by far the most efficient way to move large groups of people. But then it's excuse me, and then it's the first and the last mile that really makes the citizen's life interesting, or that's really where the big difference is. That's really where the big difference is. Now, the other part that we did was thinking of, on an American type street, what would autonomous vehicles do to an American street or American city? Because American cities, we have the boon and the bane of being very automotively either enabled or hindered, depending on your point of view, or both, actually. And we worked with Qualcomm, we worked with the city of San Francisco, just taking a look at what does it mean for the streetscape to have autonomous vehicles. And you have to remember that there are different levels of autonomy in our vehicles, from 1 to 5, And most every car has level 1. Many of them have level 4 already integrated. Where 1 is where your car beeps at you when you get close to a wall. And level 5 is where you can go to sleep and it drives you all the way to where you need to be. And the true benefits of full autonomy really wouldn't be felt until we had level 5 integrated across the entire fleet. And since America flips its fleet about every 10 to 20 years, depending who you believe, you will have 20 years before you'd have full integration level 5. And then we also have legacy vehicles, which are older cars, like and those will all still be around unless you completely get rid of them. So there's all sorts of parts to the autonomy thing, which is quite interesting. I'm a huge fan. I believe that they're going to be fantastic when they're integrated. They do also worry me a bit because they're not perfect. Nothing's perfect, but it's really fascinating.
Well, I think it's an awesome thought exercise that you're doing, and so when you approach current clients today, and how do you broach this topic? How do you get them to think about integrating for this, or is that something that you don't necessarily talk to them about?
Oh no, absolutely. For me, any engineer who calls himself a professional has a duty of care, and the duty of care means, in my view, this is Chris Luebkeman's view. This is not. I can't say this is an Arup view, but I would like to believe that we also believe this. It's our responsibility to help our clients think about what's coming. Most building codes are built upon history. They're not built upon the future. So our duty of care includes the changed climate and includes increased. Includes major disasters and also includes the changed societal memes. And autonomous vehicles will be one of those. For example, you have to satisfy. I have three frameworks: the now, the new, and the next. The now is today. The new is 3 to 5 years. The next is, like, say, 20 to 50 years. And when we, as a duty of care, have not, I don't believe just to satisfy code, but we have to be thinking about all three of these time frames and work with our clients to make sure that they're thinking about all three of those time frames. So let's say you need a parking garage for today's needs, that's great. But we should never put ramps in. It's in the sense of not make it a ramped parking garage. You have to have flat floors with ramps in between the floors, because in 10 years, the need for the parking garage is going to be changed. Also, make sure that your parking structure can be changed into an office building or into housing or into some other, into retail, whatever it's going to look like, so that you're preparing today for tomorrow's utilization. And to me, that's a professional duty of care. That's not just being wacko. That's saying, yeah, we're thinking about what your world's going to look like. We're satisfying what we have to now, but we're thinking about the new and the next with you. And frankly, the amount of cost to prepare for tomorrow is negligible compared to the cost to the client and to the planet of ripping everything down and putting it all back.
Yeah, I think that's really important what you said, though, that mindset. That, like, as you said now, the new, and the next, the three N's. I think that mindset's critical. And it kind of goes back to what you were saying earlier about problem-solving skills, about if people get in the right mind frame and they get it figured out, it's a switch, it's an important switch, but it's one that they can do. And I think this is one of your superpowers, man, is bringing this realization to the world and helping people. So I think it's exciting.
I'm not sure about that being a superpower, Ty, but what I can say to you is the following, and that is this. When I studied civil engineering in the 70s, right, 80s, the world was a very different place. At that point, we were still trying to conquer the planet. And this is really what civil engineers set out to do, to conquer. Today, in 2019, we realize we cannot conquer the planet. We have to work with Mother Nature. And to actually, the challenge today is to regenerate our ecosystems, to regenerate rather than to denigrate. And I'm very proud of our profession. I think our profession is amazing, and I'm still super excited about it. And the needs for civil engineers are profound. They're all over the world, right? But we have to have a different focus now, and that is on repair, restore, rejuvenate. And I think this is completely doable. It just takes a different mindset. So thinking, okay, not just about the needs of today, but the needs for the next 3, 4, 5, 6, 7 generations.
Oh man, I think that's really powerful what you said, and I think the younger generation gets it. I think they're into it, and I think we need We need to just make that part of our practice that we do every day. And this is a great lead into my next question. So you're an experienced dude. You have lots and lots of awesome people that you've worked with, lots of cool projects. In your opinion, what's one area in civil engineering or infrastructure that you think needs to be reinvented, and why?
I believe that most of our work today and in the future is going to really be around systems and the integration of our work as the engineer with the work of urban planners, with the work of environmentalists, the work of sociologists. So I would like to see us acknowledge and help students understand the systemic implications of our interventions. Because our tool sets today can basically do most of the monkey work, which I was trained to do. You know, I think it's important that one designs a rebar cage at some point in their career to understand the difference between a number 8 and a number 12 or number 4. And I think it's critical that every student spends time on a construction site so they appreciate that the danger and the beauty of construction. That's not just in a laptop and a flat screen, that it's real. And there are men and women out there who are making this stuff happen. And to understand how our materials are part of a system, of a carbon system, of a water system that we are basically utilizing and creating bank accounts of materials, that we're part of a system that goes beyond, like into the watershed. So when we're making designing a sewer, for example, that's part of a whole water set of a water system. It's not just green water or black water. No, it's a whole system, and that to me is a really, really critical thing. And I totally agree. I don't believe, at least from my observation, we don't do enough of that. And I'm put my hand up. I don't go around looking at schools of engineering around the world to know if that's the case, but I can see from the students we're getting, this systems thinking is not quite so cool. The second thing I would say, Ty, is we've got to focus on critical thinking skills, on really helping our students to have the tool sets to make good judgments, right? Because the good judgments, and that they're challenging what they see, they're challenging their results, and that they're confident enough to look at their homework sets, their projects, and to say, yeah, you know, I've learned something, but I find the results not quite cool. So that we're not just judging on results, but also truly judging on process. Mm-hmm. And saying, to move away from your answer is always either right or wrong. Because in the real world, there is no given with one solution. There's a given, and then there's all these contextual parameters. And so I think it's that given solve with the answers in the back of the book that's a bit of a dangerous vector to follow. Now, I understand why, and because we have to learn. There's a way to teach, but somehow we've got to figure out this contextual parameterization thing in a way which is meaningful, and I haven't really thought a lot about that yet, though.
Oh man, I think that's well said. I think those are all super important things, and I agree with you. I think we need to challenge educators out there to keep raising the bar, keep doing these things. So what is something that you're working on at Arup that you're excited about, that you can tell us? Don't tell us any of your secret stuff, right? But what is something, a project or something that you're working on that really lights you up?
Yeah, so that's a great question. There are two things I'm working on right now that I get super excited about. One is a set of scenarios looking out to 2050 Scenarios are stories, plausible stories about the future. We've taken two very critical axes, say X and Y, X being planetary health and Y being societal health, and thought of what would four worlds look like, where the top quadrant is the double positive, which we're calling the post-Anthropocene. The Anthropocene means the era we're in now, where humans are the major driver of the planet's ecosystems. And if we get away from that so that our systems have healed and people are in a really good position, that would that work. The other world, the opposite of that, we're calling Extinction Express, or the boiling frog. And that's where societal systems collapse, Earth's ecosystems collapse, as we're starting to head to now. And the one where societies are doing pretty okay, but the planet is hurting really bad, we're calling Human Inc., or Homo Deus. And this is what we're in at the moment. This is the business as usual, where people are more important than our other species and our other ecosystems. And the other one where the planet's doing really well, but societies are in a bit of a tough part, is we're calling the greentocracy. Now, and in each one of those four worlds, we have a whole series of parameters, and we're describing them. And it's really exciting because somehow we need to think of our pathways to get to reduce the carbon emissions, to figure out how to stop extracting the water at the rate we are. All these things we need to be doing, which are in many ways societal but also engineering problems. So that gets really exciting, scary, frankly. And the second one are called the planetary boundary city. The planetary boundaries are 9 Earth systems, which hundreds of Earth scientists came together at the end of the 2000s to describe. Came out in 2008, 2009, and that's a piece of homework from this little podcast, is the planetary boundaries. So how do we design our cities and retrofit our cities so that we're maintaining our planetary boundaries, which are essentially the guardrails for humanity's existence on the planet, right? If we exceed all of these ecosystems, we're stuffed. And so I'm really excited about trying to figure out how we do that in a meaningful way at the scale which is implementable building by building, system by system scale. And those are two of many projects, actually, but those are my two biggest ones at the moment. Yeah.
Chris, dude, you are an impressive dude, man. And civil engineering in the world's really, really lucky to have you. So thank you so much for all you're doing and all your forward thinking. And thank you for your time with me today. Just a few last questions. Where can people find more about you?
Well, thanks very much for your words, Ty. I do appreciate that. I'm more interested in people going to driversofchange.com. That's not me, but it's far more important, which is our website where we have lots of our publications on the future of highways, future of railways, future of retail, but also the drivers of change issues, so these trends. And it's all there for the public and for students, for faculty, anyone. So it's driversofchange.com, and that's where I would suggest folks should go. And the other place, of course, is Arup.com. You want to see some cool work, but I'll give you the drivers of change first.
That sounds great. And then just as a final thought here, do you have any other messages, any other parting thoughts that you want to leave to my viewers?
Yeah, so curiosity, Ty. Curiosity. I think, I'm very often asked, what do you look for in someone to join your team, and I say curiosity. And I say curiosity. You have to have unbridled curiosity, not just accepting everything that's given, but really understand it, to be curious about why, and asking that question, why. And there's a technique we use called 5 times why. Because usually you don't really find the answer to the question until you've asked why 5 times and answered it 5 times. Cool. So that's what I would say to our students. Be curious. The world's a wonderful place, and civil engineering is an awesome profession. So go for it. And
hey man, thank you so much for your time, dude. I've really enjoyed this. Maybe we can do, a part 2 sometime. Hey, viewers out there, thank you so much for watching. If you like this, please give me a thumbs up, subscribe to my channel, leave me a comment below. Who else do you think I should interview? I've had some amazing people on, and I hope to have some more on. So hey, thank you so much. Take care. Bye.